My guest is Michael Dray. He is the Technical Operations Manager at the California State University, Los Angeles' Hydrogen Research Facility. And he's also the manager for their College of Engineering, Computer Science, and Technology. He's a former chemical technician with GFS Chemical and a former power plant steam operating engineer for the city of Columbus in Ohio. In addition to his work in engineering, he is also an attorney. Welcome. It's a pleasure to have you with us.
Good afternoon, Nancy. Thanks for having me.
I want to know more about the largest university-operated hydrogen plant of its kind in the United States. You're the first hydrogen refueling dispenser in the United States to pass type evaluation. What's that really mean?
Well, Nancy, what that really means is that we're the first hydrogen fueling station that can sell hydrogen by a unit, in this case a kilogram, which is the convention that's used for hydrogen fuel. And we can do that knowing that the consumers are protected, that they're getting what they're paying for at the pump. This was always a difficult task in the past because it's a very challenging thing to measure hydrogen accurately at over 10,000 pounds per square inch.
You actually drive a car fueled by hydrogen. In other words, you're not going to the gasoline station like I am, or you're not plugging in as people with electric cars would do. You're putting in hydrogen. What is that kind of fuel?
What happens is we produce hydrogen at this station using renewable energy from solar and wind, and we use a process known as electrolysis. So we pump this electricity into water and we effect the chemical separation of the hydrogen from the oxygen. Then we collect the hydrogen, make sure it's very pure, we compress it and we store it, we chill it, and then we dispense it into the vehicles. And what happens in the vehicles is kind of the reverse process. These are all electric vehicles, but electricity is generated on board the vehicle. So we combine that hydrogen across the fuel cell with oxygen from the ambient air. And what happens is water is created again. And in the process, electricity is produced.
If this is safe and if this is energy efficient, why are there only about 12 hydrogen fueling stations in California? Why can't we find them on every corner the way we do gasoline stations?
I think the answer to that is that the current transportation system has over a century of development. It took us decades and decades to get here, and we're heavily invested in a petroleum-based system. But working now with all these governmental agencies and the university and private donors, like they built this station, what we're doing is we're actually capitalizing on space program technology that was developed in the 50s and the 1960s. And this is what's called fuel cell technology. We're able to exploit as sort of as a sidebar benefit of the Cold War and the space race. We're using that same technology to advance our transportation. These vehicles will be the next generation of electric vehicles. You don't have to plug them in and wait hours for them to charge. And you can take that vehicle, fuel it in 6 or 8 minutes, and drive for 200 or 300 miles. So you also have extended ranges that are competitive with gasoline cars.
And cost-wise?
Cost-wise, the cars themselves are going to be more expensive at first, and that's because to get the cost down, they need the economies of scale. In other words, they need to produce thousands of cars.
And what about the environment? Is this less polluting than using gasoline?
Absolutely. The MIT has estimated that upwards of 50,000 people per year die prematurely in the United States solely because of pollutants generated by automobiles. That's almost the same number of people that are killed in automobile crashes. The beauty of these vehicles is that only water vapor is emitted from the tailpipe of the car. Remember I mentioned that we combine the hydrogen with oxygen across the fuel cell and electrical energy is produced? The only byproduct from this process is water.
So this is a major solution to climate change, global warming.
Absolutely. When you couple our process, which we use here, electrolysis, and using electricity to produce the hydrogen from renewable energy sources, there's no carbon involved in the fueling cycle. So there's no CO2 greenhouse gas emissions.
Explain why some of the testing at your site here at Cal State University Los Angeles involves various interagency agreements, and I can't quite figure out where the California Department of Food and Agriculture gets involved. I could figure out the Air Resources Board, the California Fuel Cell Partnership, and the California Energy Commission.
Right. Well, it turns out that the California Department of Food and Agriculture, and more specifically the Division of Measurements and Standards, is charged with making sure that gasoline pumps, natural gas pumps, scales at your grocery stores, things like that, actually are measuring and reporting those measurements accurately to the public.
So they're testing.
They are testing the accuracy of our dispenser to make sure that people will get what they're paying for. So they have a very important role. But you bring up a very interesting point about the interagency cooperation and the public-private partnerships involved in this station. We have the U.S. Department of Energy, the California Air Resources Board, the South Coast Air Quality Management District, the Mobile Source Reduction and Review Committee, Cal State Los Angeles, AAA, the Amundsen Foundation, the Kenneth Brasher Trust, and finally Fran Morris Rosman and Richard Rosman. So you can see we have supporters and funding from a variety of sources. Government agencies as well as private donors.
Here at the university, you have the Sustainable Energy and Transportation Technology Program. Was it their idea to create a hydrogen fueling station?
No, actually, I think that program was operating in parallel with this one, and that now they have decided that it's a natural fit for the hydrogen station to be somewhat of a cornerstone in that program.
You've come from a background of legal work, of engineering work, being a chemist, being a power plant operator, engineer. How's this compare when you're managing a hydrogen station?
It's all kind of been very interesting, and I think a culmination of these different experiences, which makes me an expert in nothing, by the way, but the sum of those experiences have really been helpful, because when you're dealing with a new nascent technology, it's very complicated. And we have other stakeholders that we engage with, such as all the automotive manufacturers and the government agencies. So there's a quite unique collaborative environment here. And sometimes there are disputes. It's helpful to understand the technology, to have some background in power and chemistry, but it's also helpful to understand something about dispute resolution and how to bring folks back and get people to work together.
We're radio, so people can't see what this all looks like.
Yes,
so give us a little tour. Do you just pull up your car and put in the hose like you do at a gas station? And how much space is needed? What other kinds of resources do you need to create this hydrogen?
It looks from the street very much like a traditional gasoline station. A very nice one at that.
Has green, sustainable features in its design.
Absolutely, absolutely. And we're also unique in that our station is equipped with a visitor's gallery. So whereas most of these stations are behind barbed wire for proprietary reasons, for trade secret reasons, we're very transparent. And part of our mission is to educate the public. So we take people on tours.
And the public's welcome to come, even if they don't have a hydrogen car to fuel.
You don't need a hydrogen car to see how the station works, and we typically have a hydrogen car there on site so that you can see how the whole process works.
The engine, bigger, smaller than a gasoline engine?
The engine compartment is like any other modern vehicle. You open it up and you realize there's nothing I can do to this car. A lot of us who've worked on older cars in the past recognize that. But instead of an engine with pistons and with pulleys and belts, it's an electronic engine. There's no oil to leak from the engine. There is no sound. It's almost completely silent. There's no transmission with transmission fluid to leak. It's a variable speed electric drive. So this car drives like a typical electric vehicle. with the advantage, of course, that you can get much further ranges and quicker recharging times.
And how much space does it take, barrels or bins, to create and store the hydrogen? And is it safe? Because let's face it, most people think of the Hindenburg that hydrogen's not too safe.
Right. Interestingly, when we bring young children in for tours, they don't know anything about the Hindenburg. So we don't remind them of that. We kind of need to get past that. That was over 100 years ago. But no, we have no underground storage tanks like gasoline stations, so we can't contaminate the groundwater. The hydrogen is produced on site and stored safely with various types of safety protection. Pressure relief valves, ultraviolet infrared flame detectors, hydrogen sensors. So we monitor the process very carefully. There's also evidence that these cars are safer than gasoline in an automobile collision.
What are all the resources that you have to bring in to make the hydrogen?
Basically, our main feedstock is water, which we bring in from the city lines, and we clean it up quite a bit because we want to make sure that it's very pure, and electricity. Electricity is by far the greatest feedstock and greatest expense.
How much space do you need to create how much energy for how many cars?
We produce 60 kilos per day. That's the unit of measurement for hydrogen. A kilo, of course, being a little over 2 pounds. So that's the convention that's been adopted so far to sell hydrogen. It's like the gallon for gasoline. We probably spend somewhere on the order of $7 worth of electricity to make 1 kilogram of hydrogen. But that kilo of hydrogen will take you 50 to 60 miles. And we think that hydrogen can be competitive. Our method of production, because it is the most environmentally friendly way of making hydrogen, is also the most expensive.
You're at an educational institution, so you are educating, you are using this as a research facility. Students are making new discoveries and implementing other kinds of ways to be energy efficient. But is this now viable for somebody to buy a gas station and convert it and provide hydrogen?
It is, and there are regular marketing gas station sites that are looking at putting in a hydrogen pump. Many of our stakeholders, such as the California Fuel Cell Partnership, are working to help these station owners work out the engineering, work out the siting issues and the planning issues so that customers can eventually pull into a gas station and have a portfolio of fuels available, whether that's gasoline, diesel, natural gas, ethanol. Hydrogen is coming soon to the menu.
Why are you so excited about working with hydrogen?
I'm excited about working with the hydrogen movement because it's challenging, one, and it offers such potential for reasons of energy security, environmental compatibility, the public health issues, and especially in urban areas like Los Angeles, where we have huge numbers of automobiles on the roads. When we have young kids come to the station, I'll ask them sometimes, how many of you know someone who suffers from asthma? Almost without exception, every child raises their hands. So this is indeed a public health issue.
I'm so glad that you are providing this important resource, and I'd like to thank you very much for being my guest.
Thank you for having me, Nancy.
I have been speaking with Michael Dray, who is the Technical Operations Manager at California State University, Los Angeles, for their hydrogen research facility and for their College of Engineering, Computer Science, and Technology. I'm Nancy Perlman. Thank you very much for joining us, and do tune in again next week.
If you would like free information about these environmental issues, go to www.ecoprojects.org or call 310-559-9160. Environmental Directions with your host, Nancy Perlman, is a community affairs program of the nonprofit organization Educational Communications and this station.